So I recorded. Now I can start my whiteboard. And we will do our transport layer. So briefly review.
Sorry, I have a quick question about the going forward.
Uh-huh.
How will we be doing the group projects with us all being separated and online?
Yes, this is what I'm thinking now is whether we will do the group project or we will do an individual project. If you cannot find a partner, you probably will do I think it will be a good way to do that. It will be the individual.
Okay, thank you.
So please let me know through the chat board whether you want to do the group project if you can find one or two partners, or you want to do the individually so that it will no problem for everyone. Okay, maybe I will say that, okay, we still focus on the group project, but I will show certain kind of project which is also fit for the individual. Is it sound good? So something I want to do is maybe I think one person is not enough. You need a partner to share your work, and some is okay if you do the individual. Okay, then it's just to give more time to think about. I will mark the project as individual suitable or group is only for group project. Okay, that is I'm thinking. So that because I'm thinking is it's a hard time for you to meet each other. Another thing is also possible thing is you can do the group project if your group just have two persons. You can use Zoom. You don't need to pay anything for Zoom. You can have infinity talk with your partner if you just have two members in one group. So the Zoom can also work on this. So you can talk to each other through online. But I know that it's a hard time for you to group together. We practice social distance. So if you like to do individually, that's fine. I will put some projects for you to do individually. Okay, so let's. Okay, so I think I will post the projects by the end of this week so that you will have 1 month to do that, to do your project. So this one, I know that this is the big portion of your final grades. So I hope you will see that at the end of this week. If you, yeah, we don't have class on this Thursday because it's a holiday. Yeah. Okay, can I start? So let us start. Whiteboard. Okay. So I will start this guy. Where is my chatting box? Okay, here. So I will show the chat at the end, so that I can see you, everyone. Okay, so the next. Okay, some brief review. We have 7 layers, so we have already finished the physical layer. We finished data link layer. Okay, we finished network layer. And now we move to transport layer. Okay, so it's better to write upside down. Anyway, so for the transport layer, we have already learned UDP, right? So connectionless connection. And for the user data protocol. So, and we already learned some reliable data transfer, so RDT. We learn 1.0, we learn 2.0, we learn 2.1, 2.2, 3.0. So last class we finished at here. So we stopped at here. So reliable data transfer at 3.0. So what's the problem for that guy? For RDT, the problem of RDT 3.0, this one is actually the stop and wait, right? Stop and wait. So when you send out one message, then it will stop for the acknowledgement back. So the acknowledgement may be back accurately, say that, okay, I receive it, or the acknowledgement may be disrupt or lost in somewhere, and the data may be also lost. So 3.0 is more complicated, but it's a situation is that you can accommodate many network cases. Excuse me. So, but the question is the usage, or sometimes we call the throughput. Throughput is very low. It's very low. Last time we have already calculated a little bit for our throughput, right? So we calculate if we have 1 gigabit transfer, and then our round trip time is just 0.008 second, but millisecond. But our stop and wait, it will cost me 30 minutes, so RTD is too long. The transmission is just 0.008 for the transmission. You finish the data, but you wait for acknowledgement back. So in order to achieve reliability, your payoff is your usage and the throughput is the usage or throughput is very low. So how do we cover? How do we solve this problem? Actually, we will do is one way we do is called pipeline protocol. Pipeline protocol. So pipeline protocol. What is a pipeline protocol? So you treat like a pipe, like a water. So water pipe. So let us see. So this is mixing. So like a pipe right here. So previously, you only allowed one package to go from the left to the right, one package. Now, this time you allow multiple data package to go this way. So this is the pipe. Previously, you only allowed one from here to the destination, right? So this is your previous. Now, instead of just let one go through this pipe to go to this data link, and previously you will wait. If you finish, you will wait for acknowledgement. So here, So you will ACK, right? You wait for ACK back. So your data goes from source to the destination, and you wait ACK back from destination to source. This is our original RDT 3.0. Now this time, instead of just send one through this pipe, I will do, okay, I will send multiple. So I will send multiple packets. Okay. Oh, sorry. Sorry for my drawing. Actually, the packet size should be almost the same. Okay, you can draw multiple packets. Of course, at this moment, you are not waiting just for one ACK, right? You will wait for multiple ACKs. So you have 1, 2, 3, 4, 5, 6, 7, 8 go through this pipe, and of course you wait for 8 ACKs. So now we have two ways to do with these pipelines. One way we say, okay, we will go back in. So this format is to say, okay, you may ACK. There will be multiple ACKs, right? So you have so many ACKs. So how do I do the retransmission? If I don't receive ACK for certain kind of packet, or I don't do, say that, okay, I wait for certain kind of ACK to come back. But it doesn't come back. How do I do the retransmission? So one way is we do go back in, and another way we call it a selective repeat. Selective repeat. Okay, let us see one by one. So let us see what is one by go back in. Okay, I will clear. So go back in. So sometimes you will see that it is called a GVN. So GVN, what is to say? So the first thing for GVN is sender side. It can send out n packets into the pipeline. Okay, this is sender. You can send n packets into the pipeline. And for the receiver side, receiver will not, so receiver will send out ACKs, but this one is not, it will not ACK every packet. It will send out is called cumulative ACK. So cumulative ACK. So for example, I send out 5 packets, and the receiver side receive 4 packets, the first 4 packets. Then it will ACK the fourth one. It will not ACK the first, the second, third. It will only ACK the fourth one because the previous 4 it has already received correctly. So this one is called a cumulative ACK. So it will not. So send out cumulative. So example is looks like that. So receive packets 1, 2, 3, 4 correctly. Suppose n equal to 5. Okay, so suppose n equal to 5. So then the receiver will do one thing is ACK the fourth one. instead of the first packet, instead of your ACKs, your ACK 1, 2, 1, 2, 3, 4. Okay, so this is cumulative. And of course, if you have the gap, it will not ACK the remaining one. So for example, receive 1, 2, and 4, not 3 correctly. Suppose n equal to 5. And this time, since I have a gap between 2 and 4, right? So I will ACK the second one, the second packet instead of. So this one is two things for the cumulative ACK. So you should just need to remember two things. One is it will do cumulative to the correct one from the beginning to the current correct one. If there's no gap. If it's the gap, then you will stop at the last one before the gap. So the continuous one. Okay, so go back to sender. If sender send out n packets and get those ACKs, then the sender set a timer for the oldest n ACK the packet. Okay, set a timer for the oldest n ACK packet. If timer expires, then retransmit or NACK packet. Okay, so we still use this example. You receive 1, 2, 4 correctly, so we still use this one. So receiver side receive 1, 2, 4 correctly and ACK the second packet. So the sender set up the timer for the third packet. If the timer expires, it will retransmit 3, 4, 5, 3, 4, 5, 6, 7. So because your window size is 5, so no matter 4 has already been received by the receiver, right? Because it's ACK only ACK the second packet, so it will start to transmit the third one from the third one. You can see this is the good sign for this one is if you correctly receive a lot of packets, then you can save a lot of message back from the receiver, right? You just accumulative ACK. So you don't need to send back so many ACKs. But the drawback for this one is if you miss some packet in between. So in here, the example is I missed the third packet, then you will retransmit all NACK packet, no matter it's already received or not received by the receiver. In this example, your packet 4, the fourth packet will be retransmit if the timer expires. So this is go back and the advantage and disadvantage. So now we look at another one. So since the go back end has the disadvantage, so for the retransmission, you will retransmit a packet which has already been received correctly. So some guys say, okay, why not we do selective repeat? So selective repeat, SR. Okay, so the SR, the sender still can send out n packets into the pipeline. Okay, so what is the receiver side? Okay, receiver side. The receiver side will, okay, since you selective repeat, so it will say that send out ACK, individual ACK for each packet. Okay, this is quite straightforward. Okay, if I receive 1, 2, 3, 4, then I will ACK 1, 2, 3, 4. Any question? Okay, so if I send out 1, 2, 4, if I receive 1, 2, 4 correctly, then I will ACK 1, 2, 4. Okay, so then you will set up not a single timer, like go back in, you only have a single timer for the very beginning NACK packet. So the sender will set a timer for each NACK packet. Okay, so if you send out 5 packets and you have 2 packets no ACK come back, then you will have 2 timers for that packet. So if you send out 6 packets, no one get ACK, then you should set up 6 timers. So this one is a very, very big timer. You should maintain a lot of timer for different packets. So, and then if a timer expires, okay, then only retransmit the corresponding packet. Okay, so in this case, if my timer for packet 1 expires, then you will retransmit packet 1. If your timer for packet 3 expires, then you will retransmit packet 3. So you will do separately. Good sign is if you have the situation to say you receive 1, 2, 4 correctly at the receiver and the ACK 1, 2, 4, then you only need to retransmit 3 and 5 if timers for those 2 expires. Not like the previous go back in, you will retransmit 3, 4, 5 if the timer for packet 3 expires. So this one is two steps. So the 2 fundamental, both have the advantage and disadvantage. So this means that in our TCP portion, we will look at both 2. So okay, so go back in. Another drawback for selective repeat, it may have some dilemma, is if your window size is too big and your sequential number is too small, then you may get confused for the wraparound. So this one, you can look at the slides I post on the website, the transport layer. The slides, I think is 54. So it will give you that dilemma is if the window size is big and the sequential number size is small, then this one you will have trouble to distinguish whether you send out the new packet or you retransmit the old packet. So similar to the network part. Okay, so far so good. Any question? Okay, so now we can see our next one is we enter our actually TCP, the real TCP. So this is the fundamental, the real reliable data transfer. This one all is theory. Okay, now we let us see the implementation. So for the implementation, I will say, okay, TCP. So transfer control protocol. So TCP, and this one is transport layer. So the fundamental for this one is, of course, the first thing for TCP is point to point. Point to point. So this means that you have one sender and one receiver. Because you want to do the reliability, so this one is we should have one sender and one receiver. And of course, the major portion for the TCP is you should achieve reliability, right? A reliable transmission data transfer. Okay, so the TCP should achieve reliable data transfer. And this reliable means you should transfer the data correctly, also in order. So this reliable transfer is correctly transfer and receiver receives the data in order. Okay, so you should receive the data in order. Right, so this is TCP, the second one. And of course, this one should be pipelined. Okay, you should have pipelined so that it can fully use of the data link capacity, right? Otherwise, you use RDT 3.0, it will be very bad performance in usage for in the usage of the data link. So the third one is pipelined. The fourth one should be full duplex. So this one is quite easy, because this one is you should do bidirectional transmission, right, from the sender to the receiver. So the receiver can also carry some data back to the sender, not only for ACK, but also can do for put some extra data back to the sender. Okay, and the fifth one is should be connection oriented. Connection oriented. Okay, so this one we have already discussed when we compare with UDP. So this one is connection oriented. TCP has also have other stuff is called flow control and congestion control. Okay, this one is also achieved through TCP. So this one, flow control actually means sender will not overwhelm the receiver. Okay, you will not send too much data to the receiver so that the receiver may exceed its buffer at its side. Okay, and the congestion control is the sender will not send too much data to the network, which will cause congestion or collision. So this one is sender try to send enough data. Of course, when you do the pipeline, right? If you do the pipeline, you definitely will send a lot of data to the data link. So this one to the link. But you don't want to send too much data to the network, otherwise it will cause congestion. Think about during the holiday season, you send out too many mails outside, then the delivery speed will be slowed down, right? And at a certain time, it will also cause the problem, may lose your mail. So this is the kind of thing is TCP should avoid congestion. So TCP will provide the congestion control so that it will send the data correctly to the destination. Otherwise, you pipelined, but you do too much data, then you will retransmit a lot. Then your pipeline at a 3 point, it will be useless. Most of the time, it's just you do the retransmission. Okay, so now we look at the first thing is we look at our TCP segment. So what is the TCP segment look like? So TCP segment. So TCP segment, the first part is the source port. So since it's connection oriented, so you should have the source port, the destination port. So let's see. Okay, source port. Source port will be 16 bits, source port number. And of course, you have another one. It's destination. Okay, so this one is the destination port number. So similar to the UDP, so you have the source port number and the destination port number. And next portion is the most important thing is you should have the sequence number and acknowledgement number, right? So because you do the pipeline, you will do sequence number. So this is 32 bits for the sequence number, and then another 32 bits for the acknowledgement number, ACK number. Okay, so then the next portion will be head length. So you will have so many things in the next 32 bits. In here, the first portion is the head length. Okay, the first portion. Then the next portion will be not used. So this one is for later. We use it for extension. Okay, and then the next portion. So the next portion will be the urgent data. So if you think this one is the urgent data, you will do it, put the urgent data bit. We don't use it quite often. Then the next one, we use it quite often. So A bit, this tells the system that whether your ACK number is valid or not valid. This one is useful because when you send out your first packet, actually your ACK number, this area, you don't want to let it valid, right? You don't ACK anything. So you will use this bit to show that this one is not used for the ACK. So the ACK number is not used if it's 0. And then P is the push data now or not. So this one, we don't use it quite often. And the next 3 is we call it RSF bit. So R bit reset and S bit for, so S bit for start synchronization, and F bit is for finish portion. So RSF, we use it quite often. For the later, we will do the three-way hand. So when you synchronize these 2 places, then this one is we will use that RSF F is for tear down. Establish tear down, set up tear down commands. So for the connection establishment and tear down. Okay, then the next portion after this one is the receive window. Okay, so this is the next 32 bits. So headlands and UAPRSF. So this is UAPRSF are all single bit to indicate its function, whether it's a function available or not. So then the next one is the receive window. This window will be used when we use the when we do the reliable data transfer, when we do flow control and the congestion control. Okay, then the remaining part I will not draw. It will be the checksum and certain urgent data pointer, and you can have certain options. So this one is in the TCP segment. Okay, so I draw the key point. Okay, now we look at the something associated with TCP. Since this one is the implementation, it's not exactly follow certain theory, although theory is just to give us the basic picture how to achieve the reliable data transfer. But the TCP has its own style, a little bit different to our theory. So let us see what the TCP look like. So the TCP, actually the first thing is our sequence number. Sequence number. This sequence number is very interesting. It's just for byte by byte. It's not packet by packet, okay? Make sure it's not segment by segment. It's not packet by packet. Its sequential number is byte by byte. Right, this is a little bit interesting thing. And our ACK number. Our ACK number will not acknowledge what I received, but it will, this one, the acknowledged number will be indicate okay, so this one is the ACK number indicates the next byte the receiver wants to obtain. Right? So this is kind of not ACK what it has already received, but it will ACK the next byte the receiver wants to obtain. So from this one, you can see that this is actually what does it look. So question whether it's cumulative or selective. So my question, okay, I put the question on the chat board. My question is that this is cumulative or excuse me. Is this one a cumulative ACK? Yes. Anyone can answer? Okay, good. Actually, this one is accumulative. Right, is the sequence number is byte by byte, but it's just indicate if you receive correctly, you just keep receiving and then indicate the next byte. When you send back, you just indicate the next byte the receiver wants to obtain. So it can be the next byte, it can be many bytes later. So if you receive correctly, then this one is cumulative ACK. So it will not set up for each one. So this one is cumulative ACK. So this one is cumulative. Okay, so now the TCP, let us see how it works. I will clear this because the whiteboard is so small. Okay, I will draw two lines. One is sender. One is the receiver. Actually, since this one is bidirectional and you can do data, so it will do like this. So let us see the very basic example. So one host send out so this guy send out one message. Say, okay, I send out a sequential number is 42 and my ACK is 79. So the previous I received, the next one I want to receive is 79. And I send out the data, for example, I just send out one character C. Okay, this one is like the telnet. So the TCP, you do the telnet, it looks like this. So the user types one character C. So this one is, I will say the user A. This is maybe is the server at B. So user A do one thing is user type A, type C, one character, and send out to the server. Okay, user types C, and then send out to server. Server B get this character C, then it will do okay, it will do ACK, it's back to say I receive your data. And this one is, I just do the echo server, means it will echo back this character. Of course, you can do another thing is, okay, I can carry my new data. For example, I just do the new data. So, so server receive C and echo back, for example, echo back the lowercase c. So if it's do like this way, then when it's sent out, the TCP packet will looks like that. My sequential number this time, because your next one is 79, right? So this is actually the 79. And my ACK here the user one give me the sequential number is 42. So the next byte I want to get is 43, right? The next byte I want to get is 43. And I can send a data with the lowercase c. It's not echo back, but it's echoes back with the lowercase. Okay, so now you look at the sequential number is 79, is the ACK number on the top from the user A to server B. It wants the next byte will be 79. So you will see the sequential number here is 79. And the ACK from the server B to the user A, it will say that I want the next byte will be 43. And I put the data as C. So then at this moment, the user will say, okay, acknowledge back to say, okay, I received your data. So when it's received, then so it will echo back. Okay, with the sequential number equals to what? So please fill in. And what is the acknowledged number? Okay, so what is the user then acknowledge back to server B? What's the sequential number? What's its ACK number? I think almost all of you get the answer. So this time, the sequential number is the next byte the B wants. So this one is 43. And ACK number is the next byte user A wants from server B, which will be 80. Okay, so this one is the basic thing for TCP. Okay, so from TCP, now we know this, and now okay, someone want to explain why ACK is 80? Because the server give me the sequential number, the current data, the sequential number is 79. So the user, and the one data is just one character. So this character is 1 byte, right? So the data is just 1 byte. So the next byte user A wants is with the number is 80, right? It just add 1 more byte. So the next byte it wants is 80. So this is the basic. And now we need to set up the timer, right? So in order to determine whether I want to retransmit or not, I need to set up the timer. Now the question is how TCP set up the timer. So the timer issue. Okay. So some requirement. So the timer should be longer. The expiration, the time for expiration should be longer than RTT, right? No problem. If you shorter than RTT, no one can get ACK. So this one is definitely your timer, the time you set should be longer than RTT. But the question is, RTT is not consistent, right? So sometimes you transfer the data and the RTT is very short, and sometimes the RTT is very long. So if I set too short, then you have the problem that you don't get acknowledgement, but you have already retransmitted the data. So this one is unnecessary retransmission. So you cannot set timer too short. So if you send too long, then you slow reaction. If the segment is definitely lost, right? If it's definitely lost, if it's too long, the timer set too long, then you wait too long time to retransmit if the packet is real loss in the network. So the timer we should be it's not an easy job for us to do. So how do we do with the timer? We have certain kind of this one is not that we should say that this one is not based on the theory, but we just based on our observation. So how do we do? We have the estimate. We should estimate RTT. So we have estimate RTT. We have 1 minus alpha times estimate so previous estimate RTT last round plus alpha times sample RTT. Okay, let us see that what is our calculation, estimate RTT. So if we set the timer, so we want to estimate RTT, right? This one should be longer than RTT, but we should estimate our RTT because RTT is not consistent. So how do we estimate? We will estimate for each packet, for each segment, when it's transfer and come back, we look at the RTT. This RTT is called the sample RTT. We will also do the estimate RTT. We guess the RTT. And the typical value for alpha will be 1/8. So we will not change our estimation too fast with the sample RTT because sample RTT is just one packet round trip, right? So this one is too short term. But the estimate RTT looks like cumulative, so it looks like a statistics in a statistic way. So we do the estimate RTT. And then when we have estimate RTT, we also need to look at is we should give certain kind of safety margin for this estimate RTT because the timer should be longer than RTT. So we should have some safety margin, and this safety margin is provided by the duration of RTT. Duration of RTT is 1 minus V times duration RTT. So you estimate the duration RTT and plus B times absolute value of sample RTT minus estimate RTT. Okay, this is derivative RTT. So this is the calculation, and usually for A we use 0.1.5 1/8, and for B we use 0.25 to estimate. And then our timeout. our timeout will set up as the estimate RTT plus 4 times derivative RTT. Okay, so this one is kind of based on our experience. There's notes there. There's a little bit talking about the statistics. So, but for us, this one is you just need to remember that one. But if you want to know exactly what happened, why we use this one, it's more likely there is the statistics. We think our packet transfer looks like a normal distribution, then you calculate it. If you do 4 times of this derivative RTT, it will have 90% or 95% packets round trip. Will be the duration will be within this range, so it will be good. So, okay, so this is the timer issue. So the timer issue, when we finish the timer issue, now we can discuss a little bit about the TCP reliable data transfer. So for reliable transfer, so we will do this one. I will first summarize for the TCP to achieve the reliable transformation. So reliable the first one is definitely we'll use a pipelined segments. Okay, in order to make our effective transmission. And we have already said that it's cumulative ACKs, cumulative ACKs. And looks like it will do the single retransmission timer, because we just set up the timer there. We use estimate RTT plus 4 times the derivative RTT. Okay, so how do we do the retransmission? So retransmission will be triggered by 2 things. Of course, the first thing is retransmission will happen when timeout. Okay, but you will see that this timeout is still very, very long. It's not that good, so we will do another way. This is the new thing. I should say this one is the new thing. This is the new thing. Oh no. So this is the new thing, is duplicate ACKs, where we will see that and this one we will talk about later. So this guys we will talk about later. Okay. Right, this guy we will talk about later. So we just think about the timeout at this moment, how we do that one. So well, let us see what it will do. So TCP, it will from the receiver data, it will create a segment and send out the bit stream number and start a timer if not already running. So, and think of the timer as for the oldest unacked segment. And when it's timeout, retransmit a segment that calls the timeout, restart timer. If it's get received ACKs, then it will update what is known to be ACKed and start timer if you still have an ACKed segment. So let us see an example. Oh, so let us see the timeout scenario. Okay, I have the sequential number equal to, anyway, so for easy job, so 80. So last time, our 80, right? So I send out, my segment now is 8 bytes. Maybe 10 bytes easier, 10 bytes. Okay, when I got this one, since it's a pipeline, right? So it's pipeline. So at the same time, I will send out another data is a sequence with sequential number should be 90 and another 10 bytes. Okay, so in this moment, A side, and I have another one is B side. Okay, so A side send out 2 packets, one with the sequential number. One is the sequential number 80, 10 bytes. So it's 10 bytes. So the next sequential number will be 90, right? So this segment and another 10 bytes. Okay, so this time if my B receive this one is accumulative, so it will not acknowledge 80, 81, 82, 83. So it will do is a cumulative ACK and cumulative ACK, and it's the next one byte. So for this one, it will be 90, right? So this one, it will send out ACK. So I just write ACK. I will not write its sequential number in this example. So ACK, it will be 90. Okay, when B receive this one correctly, it will send out the ACK. This time, it will send out ACK, for example, at here. So ACK equals to 100, right? 100. Now the next one byte is 100. If the second ACK is received by A, but the first one is not, say it's disappear at here, you can draw like here, so this guy is not good. So we'll say no, it's not received. Okay, so this one is ACK 100 received by, this one is 10 bytes, 100. And then this guy will say, okay, this one is 100 I received. So what the TCP will do? TCP will think that, okay, I just got one ACK, and then this time the ACK is 100. Since it's a cumulative, so what's the next A will send out? If it has data to send out, No, it cannot be 110, right? So the TCP will say that 100 is the next byte I want to receive, right? So this is, the answer will be sequential number with 100. So why not why not I retransmit the sequential 80, because I don't receive any ACKs for sequential 80 packet. Because here you receive ACK equal to 100, this means that B has already received sequential the first and the second segment correctly. Even if you just get one ACK, it will be okay. A will say, okay, you have already received the sequential, the first and the second segment. And the next one you want is ACK 100. So the next one you want is the byte 100. So I will send out with the sequential number 100. So this is the first case. Okay. So what about this case? So what about this case? So what is the ACKB will send out? And for A, what will send out? If it's timeout, if this time is big enough, so suppose my time, so this is my timeout time. So okay, if I timeout it here, okay, if I timeout it here, what is the ACK number and what is the sequential number? Wait, this is the last question for today's class. So what is the ACK number and the sequential number. Please type your answer in the chat. Okay, since we only have 1 minute, I will say okay. So now I will say okay, this is the answer. Okay, because V does not receive the packet with the sequential number 80, right? So you still want to get 80. So this one is for the go back N. You look at the go back N. If you have the gap there, you will not erase that gap to say that I don't see that gap. So you have the gap between 80 to 89. So the next byte B want is 80. So this time its ACK will be 80 to say that I still want the packet A with the sequential number 80. And then since A side get this ACK, it still want 80 and it's already sent out and it's timeout. So it will retransmit. So the sequential number will be 80 to retransmit this one. So you may have a question is, what about the packet with sequential number 90, right? If you have this question, yes, it will be, it depends on your implementation. So for TCP, this time it will just retransmit 80. And for the segment 90, it will wait. Most implementation is it will wait for the next ACK. If it's the next ACK from B, say that it want 100, then A will transmit 100. So it will not retransmit 90. This is the difference between TCP and the go back N. Go back N is no matter, you will retransmit all the other packets, right? But TCP will not do like this way. It will say that, okay, it will look at the ACK back and determine whether it will retransmit for the sequential number 90. Okay, so far so good. Okay, that's all for today's class. See you next week. Yeah, Thursday is the holiday, so see you next week.